The car going around? Yeah, motorsports,
Should the car weight is decrease or increase, so just like the circular motion, so the force will be bigger.
The car weight doesn't change.
Doesn't change?
No. But, what are you trying to say? Going in a circle?
Yeah.
There's a force from the wheels. And this force is going into the center.
Yeah. Just want to increase the force.
Into the center?
Yeah.
Oh, increase the force?
Decrease or increase?
The weight stays the same. The force comes from the engine and the wheels. If you want to increase this force, you need more power from the engine, or the wheels need to have more friction to grab the road. These are the two ways. Yeah. Alright, we'll have a look at the homework now. Oh, she's doing waves as well? Yeah. Everybody wants to do waves.
I don't know.
So why did you do waves?
Because Dennis said it's better than electron.
Oh, Dennis said?
Yeah.
Better than what? Electron? You want to do electron?
Yeah.
Dennis said no?
She said the teacher is not.
Did you go to D207? That's what we were wondering. You didn't want to do the electron? Or Dennis said no? That's okay. What's wrong?
No, I see her, and she goes to the teacher's room.
Yeah.
I go to. Like this?
Yeah, X-ray. Alright, what did we do last? Ideal gas law. Was it? Yeah. Okay, let's have a look at the homework. So, I don't have my calculator, so you need to calculate for me. First question. A student drank 1 cup of coffee. How many moles of cups of coffee do you drink? Well, look who it is. Why are you so late?
Because I really left late, and I thought the class was at D207, and I went all the way there.
You went to D207 as well?
And then someone asked me for directions. It was just a very messy morning.
Right, do we have the answer for the first one? The student drank 1 cup of coffee. How many moles of cups of coffee did he drink? Did anyone get this? First one?
6.22.
Yeah.
Power 23.
No.
No. Not this way.
No, because 1 mole of coffee equals 6.02 times 10 to the 23 cups of coffee. So then that means 1 cup of coffee is 1 over 6.02 times 10 to the 23. So 1 cup, how big is this number? Yeah, can you get it, Andy? This number?
1.66.
1.66, yeah.
10 minus
10 minus
20.
24 moles of coffee.
How does 1 cup of
Hmm?
How do I 1 cup?
So I said here, a student drank 1 cup of coffee.
What is 1 mole?
What I'm saying is 1 mole is 1 Avogadro from chemistry as well. But I don't want this many cups, I only want 1 cup. So I need to divide by Avogadro's number. So here it's 1, there's 1 divided by this number. I bring it underneath. Is it okay? Yeah? Is that okay? Yeah. Number 2. Number 2. air is 70% nitrogen and 30% oxygen. What is the average molar mass of air? Okay. So it's easy if you think about it as like 100%. So 70, or if you think of it as 100 parts. So 70 parts, that's nitrogen. Now, is it nitrogen N or N2? N2?
Two.
We can check here. It is N2? Yeah, 2 nitrogen. And oxygen is 2 oxygen as well. Okay, that's great. So, there's 70 of these, and then there's 30 of these. Yeah. What's the molar mass for nitrogen 2? What is it?
28.
Yeah.
0.0134.
Grams per mole. Yeah. And then for oxygen, what is it? 9988 grams per mole. So do you know how to get an average? If you don't... Yeah, well, this is the thing. It's not 2. It's 70 of these and 30 of these. So there's 70 of these and 30 of these. So it's like 28 plus 28 ... plus, 32 plus 32 ... Do you know what I mean? Like there's 70 nitrogen and 30 oxygen, and then you add and divide by 100. So you could say it's 70 times 28.0134 plus 30 times 31.9988 all over 100. What's that, please? 29.209. So we'll just say 2 grams per mole. This is for air. Is that okay? Did you get that or not? No. Did you add and divide by 2?
Yeah.
So if you add and divide by 2, you probably got an answer. Well, it should be nearly the same, was it?
I used the molar mass multiplied 1 plus 30.
Okay. You know it now, yes?
Yeah.
Okay. Right, next. Number 3. A cylinder of argon is at 1.5 atmospheres and it's 50 litres. What would be its pressure if its volume is reduced to 40 litres? Okay. So you have your gas, and what's the pressure? 1.5 atmospheres, and the volume? 50 litres. And then what happens to the gas? Does it get bigger or smaller? It's smaller. It becomes 40 litres. So we can use here Boyle's law, because the pressure, the volume, it was multiplied by 0.8. So the volume was smaller. So what happens to the pressure? Increase. So divide by 0.8. Or if that's confusing, you can write it like this as well. The pressure, how do we make 50 become 40? Divide by 1.25, I think. Is that right? 50 divided by 1.25? Is it 40?
Yeah.
So then that means the pressure is multiplied 1.25. So it's 25% bigger. So what's that? 1.25 and 3. 1 point. No, I can do this. I can do this. I know I can. I'm just tired. 1.37? No. 875?
Yeah.
All right. So this is the pressure now. Sorry, the pressure atmospheres. Are you eating like porridge or something? Okay. Did anybody use Boyle's law for this one? No. What did you try to use ideal gas law? Yeah. Did it work?
No,
How come?
nothing comes.
You could use ideal gas law. So here in the first picture, what's the pressure? It's 1.5 atmospheres. Now you'll need to change this into Pascal, so that's, what's it, 101.35, isn't it? And the volume, you need to change that into meters cubed. What's that, 10 to the minus 3? The N, you don't know. Yeah, okay. The T you don't know, but here, the P you don't know, the V you do know, the N you don't know, but you know it's the same, and the T you don't know, but it's the same. So if you have here P times V, that equals N or T. And here, P, which you don't know, times V equals N or T. These are the same, aren't they? So you can make this equation. 1.5 times 101.35 times 10 minus 3 times 50 times 10 minus 3 equals P times 40 times 10 minus 3. Cancel. So we can bring this over here, divide by 40. Well, this here, remember, is just 1 atmosphere. So it's 50 over 40, multiply 1.5. So that's 1.875. Come on, Grace, focus. P. So 1.875 atmospheres. That's P. So if you can use the ideal gas law, you have to do it like this, but it's longer. Yeah, you have to do it like this, but it's longer. So it's easier if you use Boyle's law. Yeah? What's wrong with you?
If they don't specify it as a temperature change, then just assume that it's...
Yeah, I really should have said the temperature's the same. My bad. Is that like chocolate bread or something?
Yes.
Or fruit bread? Little chocolate pieces, yeah? Looks good. Where'd you get it? Tesco, wonderful place. Okay, next. I can go to the next one, yeah? No? Did you get this one, Andy?
I was stranger.
You didn't get this answer?
Yeah,
What did you get?
1 point. I just didn't use the Boyle law.
Okay. Continue now. Next, a tank of oxygen is at 3 atmospheres at 20 Celsius and it's 100 litres. How many atoms of oxygen are there? Okay. This is a Lorraine question, isn't it? Isn't this something you do with Lorraine? You know Lorraine, your chemistry teacher? Yeah. You do this type of question with her?
No.
P, V, N, or T. So the or 8.31, the N we don't know. What's the volume? 100 liters, which is 100 times 10 to the minus 3 meters cubed. Is that right? And what's the pressure? 20. What? 3 atmospheres, which is 3 times 101.35 times 10 to the 3 pascals.
Minus. Oh, 3.
Yeah. You put minus? Oh my goodness. Okay. And what's the temperature? 20 Celsius, which is 293 Kelvin, is it? No. Is it 293? My goodness, I'm so tired.
293.15.
Yeah. Okay, so PV equals N or T. So N equals PV over RT. So that would be 3 times 101.35 times 10 to the 3 times 100 times 10 to the minus 3 over 8.31 times 293.15. What's that, please? 12.48. Yeah?
No.
No? Is it this?
Yes.
Okay. So that means, yes? You need to write this down? Sure. Yes, continue, Grace. Yeah. Now, what you have is 12.48 moles of oxygen. So that means you have 12.48 times 6.02 times 10 to the 23 molecules of oxygen. Yeah? This is Avogadro's number. Harry, can you give me this number here?
Um, 7.51 times 10 to the power of 8.
Molecules of O2. So how many oxygen atoms do we have?
Times 2.
Yeah, because this is O2, so there's an oxygen and an oxygen together. Yeah? So you have this many of this pair. So that means,
1.5.
what's it, what is it, 1 point?
1.503
What?
times 10 to the power of 5.
Atoms of oxygen. Is that okay? Yeah? From here to here, is it? I multiply by 2. because this is how many pairs. You do this with Lorraine, right? Questions just like this?
Long time.
Like 5 weeks ago?
Long enough.
Oh, 6 weeks?
Much more longer.
Can't be that much.
Yes, very much.
Very much, alright, okay. Next. Lastly, yes. Can I do the next one? Okay. In Ireland, the average temperature is 10 Celsius. Nice and warm. Your teacher is driving a car, and the car releases 119 grams of carbon dioxide every kilometre. The car is travelling 120 kilometres on the motorway for 1 hour. What is the volume of carbon dioxide released? So what you have here, here is the motorway, here is the car, here is the teacher, and it's 120 kilometers per hour. So in 1 hour, how far has the car travelled? 120 kilometers. Now, every 1 kilometre, how much CO2 comes out? 119 grams. True? Yeah. So, if that's per kilometre, then the total CO2 is 120 multiplied 119 grams. What's that, please? 14280 grams.
Why are we multiplying?
Yeah, in the question it says it's 119 grams of carbon dioxide per 1 kilometre, each kilometre. Yeah. Yeah? My car doesn't have wheels. Yeah. I know. We'll make it a floating car. Hover car. Yeah, that's better. Right, now I need to know how many moles I have. So CO2 is 1 carbon, 1 oxygen, and 1 oxygen. Yeah? What's the molar mass of carbon? 12? Of course, that's the definition of them, yeah. And of 16 for an oxygen and 16 for the other oxygen. So then, what's the molar mass for the 3 of these guys together? 48. So this 44 grams per mole. That means a mole of CO2 will be 44 grams. 1 mole will be 44 grams. So then how many moles will I have? I have 14280 divided by 44. 324.6 moles. Yeah?
If you want to do it that way, 324.5.
324.5? Okay. Right. So, do we know the temperature?
Yes.
Yeah, what is it? 10. So this will be 283.15 Kelvin. Do we know the volume? No. That's what we want. Do we know the pressure? No, but it should be about what? 1 atmosphere. 101.35 times 10 to the 3 pascals. So if you have PV equals N or T, that means V is N or T over P, which will be 324.5 times 8.31 times 283.15 all over 101.35 times 10.3. Are you crunching that, Harry? Yeah. What you got? Yeah. Say again, Andy, what's it? 7.5 or 75? 7.5 meters cubed. 7,500 liters. So that means the car, the CO2 that comes out from the back, that's 7,500 liters for 1 hour. Huh? Yeah, much bigger than the car, yeah. Well, no, actually, no. Thank you. I guess it's actually not that big. Anyways, this one probably more difficult than what you do with Lorraine. Yeah? Okay. By the way, this question here, this was like a section A question.
Section A.
Yeah. But in the exam, listen carefully, you do not have a periodic table in the exam. So in the exam, they give you this number in the question. Okay. All right, let's continue. So